My name is Michael. I'm an operations engineer at Wave. We're a fintech company here in Toronto, building services for small businesses, things like payroll, invoicing, payments, accounting, that type of thing. So a while back, we were tasked with building a data lake for our company. I kind of went into that process with a whole bunch of questions. What is a data lake? All this stuff. And coming out of it, I still have a bunch of questions. So it's a pretty vague term that you hear a lot these days. But in our case, it really meant aggregating data from all of our applications into one place where we could use it for other things. So this was a challenge for us at Wave for a few different reasons. We have over 350 databases spread across 40 plus RDS instances. So this is supporting multiple applications. I think we're at around 35 applications. We have a combination of MySQL and Postgres, and those are sharded. Some of the applications have sharded databases, some are unsharded. So that's where you'd see we might have 4 RDS instances with 16 logical databases on them. That lets us scale out by spinning up some new nodes and then moving the data across. We chose S3 for the data lake as kind of a lowest common denominator for our data. So once it's there, it can be loaded into Redshift for our BI team to do their analytics work, kind of like the last talk. It's available for our ML team to do their machine learning, building their models and doing the training. And in the future, we want to look at things like Athena and S3 Select, which give us even more opportunities for analytics on our data. One of the requirements was that we needed to dump these databases every night at a minimum. And we do full database dumps. It's not kind of an incremental thing. Some of our applications or some of the things we want to do with the data require even more frequent access. So we have some that dump multiple times a day. And that's for things like fraud detection and that type of thing. And then we have a privacy policy with our users, which says if you close your account, after 60 days, we're going to delete everything. And that includes everything in the data lake, which introduced some interesting challenges. So you might say, why not Glue, right? This is Amazon's kind of native ETL solution. It sounds like it's built for this. And that was what we thought when we first started this process too. We ran into some issues when we first started experimenting with it, particularly around our Postgres databases. I think these have been resolved, but they were kind of a blocker for us at that point, so we kind of moved on with another solution. Our team also really didn't have a whole lot of expertise with Spark, which is the underlying technology for AWS Glue. With that said, we're probably going to continue to look at it in the future. What can it do for us? You can also run it off of S3, right? So you can pull data from there and use it to transform. So we're definitely keeping our eye on it and going to do some more experiments with it. So what does the architecture look like for the tools that we've built to do this? Kind of as mentioned, we have a certain set of tools that we do. So we use AWS Lambda, as well as Cloudformation, the Database Migration Service, or DMS, SNS, which really is just kind of a message bus for the events that come out of DMS. And we also use Terraform. And I'll get into why we use both Terraform and Cloudformation in a little bit. So I'm not sure how well anyone can see this, but it was kind of our initial design of the system. The end result came out pretty similar to this, but had a few changes that I'll get into. So the way it works is you take CloudWatch events, which you can set up on a schedule, right? So you can set it with a cron expression. That kicks off a Lambda. That Lambda can create the CloudFormation stack for all the DMS resources that we need, and register. DMS can register with SNS, which gives us information like the DMS instance is created, the task is ready to go, a task is completed, that type of thing. Logging all goes to CloudWatch logs. and we kind of subscribe to that SNS topic to also see when a task is completed. We can do some cleanup. So that was the initial design. It was kind of, we thought we'd use one Lambda that would kind of handle all of these events. But when we actually got into the weeds, we kind of ended up breaking it up a little bit differently. So we ended up with 3 Lambdas. The first one is called the ArtCreator. So this is kind of similar to the first part on the slide. And we actually end up with one of these for every database that we're dumping. So we've got, like I said, 350 plus databases. So you end up with actually 350 different Lambda functions. They're all spun out of the same thing. So that takes a CloudWatch event on a cron, which triggers the Lambda. That Lambda creates the CloudFormation stack, which includes the DMS instance, the DMS task, and the S3 target endpoint for DMS. And it also registers the task to that SNS topic that already exists, which just says, when I have an event, send it over here. The second Lambda we have is quite simple, and it's called the manager. It just listens to those events on the SNS topic. When it sees one, the Lambda spins up and checks what event it is and some of the payload that comes with it. If it was, the task has been created and is ready to go, it just calls back out to DMS via the API and says, okay, start your DMS task and start dumping the data. And then the final Lambda that we have, we ended up calling it the Reaper. This just runs every minute with the same way that things start with the CloudWatch events. So when that runs, it does 2 things. It looks for any failed CloudFormation stacks that are part of our data project. If it finds those, it just cleans them up as if they exist. And the next night we try and run this again, it would kind of run into the naming collision and wouldn't work. So we need to make sure we clean those up. In addition, it queries out to DMS via the API and looks for the tasks that have completed, which means all of the data has been moved out of RDS and into S3. When it finds those completed tasks, it basically parses out the metrics that DMS has for it. So things like how many tables have been transferred and completed, were there any failures, how much data was moved, that type of thing. Parses that out, sends it to CloudWatch logs, and then when that's complete, it just deletes the CloudFormation stack. So if you're familiar with Terraform and CloudFormation, you might be wondering, why are we using both of these, right? Terraform is kind of the main tool that we use at Wave to manage most of our AWS infrastructure. So that's kind of our go-to. If we're building something new, we're looking at how we can do it with Terraform. But when we were looking at how to build something like this that kind of spins up these stacks of resources on a repeated basis, and they're ephemeral, right? They come up at night and then they go down again. Terraform has a bunch of extra management that you need to do. So you need to have the remote state for each stack that you build and kind of move those pieces around. CloudFormation has all this kind of built in. So you get a CloudFormation stack. That's all you really need. You don't need to store anything in S3 or somewhere else. So that made a lot of sense for us. And then there were a couple of resources that Terraform didn't support. So DMS, it's a really nice service from AWS, but I think it's not as popular as a lot of them, so Terraform just hasn't built out the full support. So things like DMS event subscriptions, you just can't do with Terraform without kind of building it yourself. So if one of our developers is launching a new app and we want to move the data that's going to be there from RDS into S3, all we really need to do as a team is do some Terraform configuration. So I need to configure remote state to just read some data about our various functions and things like that. So that's a pretty simple point it at the bucket that stores the Terraform state and give it the key. Then we need to instantiate our module. There's not really anything custom to the application here. We're just passing through some variables. So it's pretty straightforward. And then we already have RDS modules for Postgres, for MySQL, for sharded, for uncharted databases. So we just need to make a few more modifications to that. So if we don't have read replicas, we need them. This project doesn't pull data from our production databases, right? Because it does do a lot of reads. It could impact performance. So you need to use it on read replicas. And you also need to say, I want to create DMS endpoints. That's basically what tells it, OK, we want to pull this data out. And then, again, we pass through a few more variables. But it's pretty simple. If you want to customize the schedule or things like that, that's just a few more variables that you pass through. So once we had built this and got things, things were working, but we didn't really have a lot of insight into what was going on a nightly basis, right? You spin up a Cloudformation stack, and then you delete it. All the resources are created and then deleted. So you need a way to keep an eye on things kind of, even when those resources don't exist in AWS anymore. So we use a couple of tools. I think they're all vendors here. Datadog we use heavily at Wave. So that's one. Datadog gets all of the AWS CloudWatch metrics, automatically just sucks those all in. So here's an example of what our read replicas look like when this process kicks off every night. So you can see it around 1 o'clock is when things start. It takes a while for the CloudFormation stacks to spin up, for the DMS instances to be created. So you can see it around 1:15, things kind of go a little nuts. Each of these colors is really just a different read replica that we have. So you can kind of see some are active for a short period of time. We have some down here at the bottom that are running for hours. Those are our biggest databases, right? It takes a decent amount of time to suck all the data out of them. So this gives us some insight into what impact this is having on our systems and just what's going on behind the scenes. Obviously, there's a lot more data in there as well. We also use Summa Logic, which is another great tool. So earlier I mentioned the Reaper parses out the DMS metrics from their API and logs it to CloudWatch logs. Once it's in CloudWatch logs, another Lambda sends that over to Summa Logic, where we can do all sorts of analysis on the logs, parse metrics out, parse fields out, and build out queries, save queries for our teams, or dashboards like this one. So this is at a high-level view, what we can do with that. We can see, were there any replication failures, how much total kind of data volume was moved in the last day. So the top 4 here are kind of on a daily basis. How many tables were pulled out of RDS and into S3? How many tables failed, right? So DMS can have errors reading a table. So we can see, were there any failures there, so we can go fix that up. And then below, you get kind of the same view, but over the last week, just to kind of see, are there any trends of things are starting to go wrong? So those are 2 great tools that we have. Any large project like this, I think you're going to run into some unforeseen issues, some things you weren't really expecting. So I'm just going to run through a couple of those. So if you've used AWS much at all, you're probably familiar with their service limits, right? A lot of times these are in place for your own good. But we definitely hit a bunch on this one. We had to upgrade or get the limits increased, a bunch of them for DMS. I think the default was like 10 or 20 instances. We needed hundreds of them. So the endpoints, the tasks, the instances, and event subscriptions. We kind of expected that, right? That was, DMS was a large part of this. The other 2, we kind of caught us by surprise a little bit. CloudFormation stacks was another limit we had. And again, we needed hundreds of CloudFormation stacks, which previous to this, we were running maybe 20 or 30, and now we're spinning up 300 a night. And CloudWatch event rules was another one that surprised me. I'm not sure why, but you can only have, I think, 100 by default. but these were all bumped up by AWS, no problem for us. Figuring out how to size the DMS instances appropriately took some time. You're really balancing how much you're paying for the instance versus how much time it takes to dump an entire database. Our time limit was we wanted everything done within 3 hours because our BI team needs to kick off their process to load it from S3 into Redshift. They need to know when they can run that. So really, if anything was taking longer than 3 hours, we wanted to bump up the instance size. And then on the other side of things, DMS bills you on an hourly basis for the instance. So EC2 recently, or not so recently anymore, but they switched to per minute billing, which is awesome. So we've asked the DMS team to do the same just because we have some smaller databases. We spin them up for 3 minutes and we pay for an hour. So you're just balancing costs on both sides. And then DMS is an awesome service, does great for us, but you still run into things like a task says it's ready, but it's not able to connect to the database, so it just hangs there. The DMS events that we diagrammed out earlier, we expected them to be a little bit more granular. So you can get information like this task is completed, but it doesn't tell you anything about was it successful, did it fail. So that's where we switch gears into, instead of just reacting to the event, we query out to the API to get more of that information. And then DMS rate limiting. So if you go back to that Datadog slide, you might notice that things are spinning up over, let's say, from 1 o'clock to 2 o'clock. When we first tried spinning up 350 DMS instances at the same time, and then starting those tasks, we hit rate limiting, which is built into the DMS service. So really, we just need to add some math to the Terraform and spin things up over that hour to get around that. So that's about it for this. It's been working well for us for, I think, at least the last 6 months or so. Our BI team is fully using this data. It's being loaded into Redshift. It's been an adventure figuring it all out. So if there's any questions.
Great, thank you, Michael. Yeah, so questions, here we go.
Hi, what format do the databases get dumped into S3?
Yeah, so DMS right now, we use it and dump it just as plain CSV into S3. They are, I believe, or I'm not sure if they've added or it's on its way. We've talked to them about getting Parquet format. But for now, CSV. Our main use case right now is getting it into Redshift, so they have the Redshift load command that can just pull that in.
Hey, I'm curious why you decided to use Summa Logic for queries and dashboarding. Why didn't you use Datadog as you were using that for other use case?
Yeah, so Summa Logic was chosen not just for this, but we use it all over the place for all of our application logs. We just get everything into there. So I know Datadog has their logging now, but Summa Logic is where it all is right now for us, so we're using the same tool.
Yeah. Could you elaborate a bit what kind of CloudWatch events trigger the Lambda, and what programming framework are you using in the Lambda itself?
So most of the Lambdas that are triggered during to kick off the process, those are just, you can do CloudWatch events. I think they're called scheduled CloudWatch events. So it's a CloudWatch event that you just give it a cron, a cron, and tell it what to kick off at that time. Sorry, what was the... Oh, for Lambda. Yeah, we're not really using a framework. We package it up with serverless application model, so we use that to publish. But it's just a couple simple Python functions. Yeah.